Good evening, everyone, and thanks for coming to the last session of this first day here at TechDays. So, in this last session, we are going to be talking a bit about some advanced concepts in Silverlight. I marked it as a level 400. It, of course, depends on your knowledge of WCF of Silverlight, so depending on that, it will be between 300 and 400. So the goal of this session is basically to give you some insight in some more advanced concepts, things that you may already know, may not know that exist, or may have heard about, but don't really know how they actually work in Silverlight. We're not focusing on any specific version. We're going to see things that are sometimes already in Silverlight since version 2 or 3. Some are specific for Silverlight 5. So a very brief introduction about myself. So my name is Gilles Kleren. I work as a .NET architect at Ordina here in Belgium. I'm a Microsoft RD and a Silverlight MVP. And I've written a book on Silverlight, which is Silverlight 4 Data and Services Cookbook. And the version of Silverlight 5 is going to be released in a matter of weeks. I've put up my blog, my email, and my Twitter, so you can follow me on Twitter to ask questions, to see what I'm doing in the terms of Silverlight and Windows 8 Metro. So what are we going to talk about? So we're going to start with some deep dive in duplex communication. That will take about 25 to 30 minutes. We're going to see several ways of doing duplex communication in Silverlight. Then we're going to take a look at MEF, how to use MEF to split up the ZAP file. We're going to take a look at security, secure communication, using ASP.NET membership in Silverlight applications. I'm also going to show you how you can use the iNavigation content loader interface, which is an interface that was added in Silverlight 4. To actually allow you to get a hook in the navigation application template. We're going to see some new stuff in the Silverlight 5 data binding engine. And I think around that time we'll probably have to stop because we apparently have to leave this room around 6:50. So if we have time, we'll see. We'll maybe take a look at uploading and downloading, vector printing, and unit testing. So we'll see where we get. It's all separate topics, so we can cut it off anywhere we want. All right. Small plug. You can win something by tweeting a very simple tweet that contains the TechDays BE Telerik tag that you can see over there. By simply tweeting about this session with that tag. Between today and tomorrow morning, you can win one of the licenses offered by Telerik for the complete Red Controls toolkit. And I will contact you if you are one of the winners. So simply tweet with that tag and you can win. All right, so let us begin by taking a look at duplex communication in Silverlight. Duplex communication, I assume everyone is more or less familiar with what duplex communication means. It's basically two-way communication, where the server as well as the client can initiate communication. That is what the duplex communication basically does. Now, is such a thing useful in Silverlight applications or not? Well, that depends on the scenario. And let me first tell you a few scenarios where duplex communication may or may not be useful. Assume that someone asks you to build a Silverlight application that should give you updates while it's open on your screen, should give you updates about some football match or something. So that guy has made a goal, that guy has fallen down, and so on and so forth. I don't know anything about football, but anyway. So if you would build, or if you are asked to build such a Silverlight application, how would you do that? Perhaps you would build your Silverlight application with a timer that every 30 seconds or so goes out to a service and asks that service, are there any new updates? Perhaps every 10 seconds, perhaps every 5 seconds. And so most of these service calls are going to result in a response from that service. The service is going to say, well, yeah, here is an update. That guy has made the goal, or I don't know what. So in most cases, the requests made by your Silverlight application are going to get a useful response. So for that type of application, that could be a good solution. Just having a timer that pulls a service every 5 seconds, 10 seconds. Now, assume that someone else asks you to build a Silverlight application that shows on the screen your voicemail messages, for example. Now, probably you don't get a new voicemail message every 30 seconds, at least I hope not. So if you build that application in the same way, again having a timer that pulls every 30 seconds, are there new messages for my user here? No, there aren't any new messages. Are there new messages? No, there aren't new messages. So I mean that most of the requests made by the Silverlight application to that service will probably end up being useless because the response is going to be empty. There is nothing to see. There's nothing to give you as an update. So in that case, you are going to put load on the server, which is basically completely useless because there is nothing to say from the server side. If you have just one end user, one user of that Silverlight application, it's not going to be a big problem. But if you have thousands of users pulling that service and most of the requests being or ending up in a useless response, it's going to be creating a lot of load on that server without actually being very useful. So in that case, having the server connect with the client would actually be a lot more useful. So I hope that I've shown you that some scenarios really would benefit from the fact that the service would actually be, or it in general would be a better thing if the service or the server would be able to contact the Silverlight application once it has to say something. So perhaps today there is a new voicemail message and tomorrow is another new voicemail message. So in that case, only at those points the service would say, well, Silverlight application, here's an update. So the server would then push that information to the client, and indeed it would be a better thing. So push is indeed, in some scenarios in Silverlight applications, a good way of building the application. So it's going to create more scalable applications because in that, if you build your application where the service can actually push information to the client, it is going to be more scalable. More clients can be connected with the same server because only when the server is pushing something, it's going to create load on the server. It's not going to create all kind of useless requests on that server coming from the clients. It's going to only create some load on the server and more clients can be connected. And the updates are going to be faster as well. You can say, well, I'm going to bring down the poll time. Perhaps I set it at 30 seconds, but that might be a bit too high. So maybe I bring it down to 10 seconds. But that is that results, of course, in bringing or increasing the load on the server. Because if you poll every 10 seconds or every 30 seconds, it's 3 times as much requests that end up on the service. So finding a balance between scalability and speed is very difficult in a poll scenario. So indeed, pushing would also give updates faster on the client side. Now the problem, of course, is that, like the last sentence on the slide says there, HTTP is a request-response protocol. No response can be generated without there being a request. So that might be a bit of an issue. Okay. So with this, I hope I've shown you that there are places where a pull and push is, a push scenario is much better than just having a pull scenario. Now, Silverlight, in fact, offers 3 ways of doing duplex communication. There is the HTTP polling duplex, which was introduced already in Silverlight 2, was so complex that actually no one could figure out how it actually worked, I think. And then they improved it in Silverlight 3 and made some minor changes in Silverlight 4. We're going to see that as the first solution to doing duplex communication. The second one is sockets, TCP communication, which has been around since Silverlight 2, has had some minor changes in Silverlight 4. And then in Silverlight 4 also NetTCP was introduced as another way of doing duplex communication. We're going to see these 3 ways that are built in the Silverlight platform to do duplex communication. There is in fact a 4th way of doing it, but as you can see, this guy is also trying something himself which may not end up working very well. Doing it yourself is basically what I explained in the first slide. Doing or creating a poll system that every 30 seconds or 5 seconds or 1 second is going to do a polling to the service. That is very difficult to balance out between the speed of or the response or the poll time and the load on the server. So that's very difficult to do. So you shouldn't be doing a duplex scenario yourself. So we're going to start by looking at the HTTP polling duplex. And as you can see, I've added here a screenshot of a film that you may know, The Illusionist. Now, why did I actually put up that screenshot of the illusionist there? Well, take a look at the name, HTTP polling duplex. We just said that HTTP is a request-response protocol. So it's not a good way, or it's in fact not possible to do or send a response without a request. I also said that polling is not a good idea. Remember the slide with the pizza. And still, the HTTP polling duplex is the first way of doing duplex communication. Now, how does this actually work? Well, there is a system built in Silverlight called smart polling. And smart polling does the polling on a lower layer than pure HTTP. So it actually goes over HTTP, but it does a request on the network layer. And it in fact does request every few milliseconds. So very fast it starts polling the server. So basically it is certainly not duplex communication. It is in fact a very fast polling client, polling every few milliseconds to that server. And on the server side, messages are queued up, waiting for the response, waiting for the request to come in. And when there is a message waiting on the server, it's going to be transported to the client, creating the illusion of duplex communication. So every few milliseconds, the client asks, is there a new message? No. Is there a new message? No. Is there a new message? Polling is happening on the network layer, and that is called smart polling. And it is built in Silverlight, so it's built in the platform by Microsoft. And it is done through a specific binding called the polling duplex HTTP binding, which you see there, which basically inherits from the basic HTTP binding. And it uses a few binding elements. So the HTTP as transport is going purely over HTTP. It is using net duplex protocol and WS make connection. The net duplex protocol is actually to create a connection from the client to the server, and WS make connection is actually to transfer the message from the server back to the client. But as you can see, it is HTTP. It therefore doesn't require me to open specific ports, and it works over the internet. You'll see later that HTTP polling duplex is the only way of doing duplex communication over the internet. There is no other way of doing duplex communication in an internet scenario. There are other ways to do over intranet, but not over internet. And we said that that client is continuously polling that server. It doesn't keep on doing that. There are some timeouts or some places built in where the polling stops. So the client polls, and all of a sudden there is a message on the server waiting to be transported to the client. Then the polling stops because it has to transport that message to the client. Afterwards, it starts polling again. If a fault occurs, the polling also stops. That is quite normal. And then there's two ways or two timeouts that can occur. The first one is the poll timeout. The poll timeout is basically after 1 minute, after 60 seconds of polling, the polling actually checks if both sides are still there. And if they are still there, an empty message of HTTP 1.1 to 100 message is sent over the wire, and they start polling again. They do that 10 times in a row, and at that point, the inactivity timeout occurs. And so basically after 10 poll timeouts, so 10 minutes of no communication whatsoever going over the line, it actually times out. And so then the communication is closed. Now, it is managed purely by WCF. So if you have a scenario where you say, well, I have to perhaps wait an hour before a new message is going over the line, well, simply change some parameters in the WCF configuration and it will keep on working. You can configure this entirely. It's based on WCF. Now, the service, as mentioned, is a WCF service. It's very similar to a regular service, apart from a few things. It has a regular contract, a service contract, and it also defines something called the callback contract. The callback contract is basically, so remember that we said that it seems like the service is calling the client. It's basically preparing a message on the server side that has to be transported to the client. Now, that callback contract that you define in your service contract is basically saying, well, this is the instance of my client. I want to do something with my client on my service. I want to invoke a method on the client. That is defined in the callback contract. The methods, the operations on my service are defined with the is one way equals true. Is one way is true is basically saying on that WCF service, create a call, but don't wait for the response. My client will connect to the service. It won't wait for a response. The service will send a message to the client. It won't wait for a response to return. Basically, why is that? Because it's duplex communication. My service doesn't know if the client is still there. It's basically sending that message and it doesn't wait for a response to come back. The get callback channel in T, we'll see that in just a second in the demo. It's basically a method that creates a callback channel in the service code itself to get instance to that client. The service itself works as a single-threaded service. So all the clients that are connecting with the service are connecting with the same instance. So that also effectively means that if you have a third-party service or a file system watcher or whatever that has to send updates, you can do that from that one single service instance that is running. And then the client. Well, the client, you can create a proxy. You have to create a proxy. It's just as I would do in a regular WCF service. However, there is no configuration code being generated. So that means that you have to do some more work yourself. What you see here is I'm creating the binding myself. I'm creating a custom binding, passing in the several binding elements from the client for the client communication to be built up. As you can see, I'm creating an HTTP transport. I'm also adding binary message encoding and then pulling duplex binding element as well. And this is going to set up my binding from the client because I can't do it via configuration code. Then the client registers with the service and then it can start communicating. It also happens on the UI thread, which means that you don't have to do marshalling back to the UI thread, so you don't have to do any dispatcher begin invoke or whatever to get back to the UI thread. All right, lots of theory. Let's take a look at a demo. Now, the demo scenario is something typical for Belgium. We're going to talk about train delays. So assume that the train company has a third-party service that generates an XML file when a train is delayed. And it drops that XML file with the train delay on a specific location. That is my third-party service. And then I have a WCF service that monitors a specific directory and sends out an update to all connected clients from, so Silverlight clients, via duplex, HTTP polling duplex. That is the scenario. Okay, let me first show you the scenario running. So I'm going to start this duplex trains demo. You'll be able to download all the code afterwards from my blog. So don't worry, I'll upload it maybe tomorrow. I'll try. Okay, so let's try running this sample. I am going to be the third-party service. I'm going to manually drop XML files in a specific location. So as you can see at this point, purely theoretical, there are no train delays, which is highly impossible, but anyway. And so I am that third-party service, and I'm going to, let me make it a bit smaller to get it on that screen. It's not going to be easy, managing all those screens. So I have here a folder which has some typical files that are generated by the third-party service. So I'm going to try copying that file in here, and boom, you see, it's falling off a bit, sorry. You see that service has now pushed information to the client. I'm going to try that again with the second file. Boom. And you see that it happens immediately. Although it is not actually pushing, it's my client continuously polling, it's actually giving me the illusion of being immediate. It's like the service is pushing it out. I've also implemented that the train delay is gone, so this is a remove message, which is then pushed also to all the clients. And of course, if you have multiple clients, it of course will push this to all connected clients. And I'll show you that in the code. All right, let's close this thing down. Let's take a look at the code. So in my code, I have a train delay service, the contract, that's open over here. And as mentioned, it is a WCF service. So it has a service contract, and it also defines a callback contract, which is basically the contract that is used on the service to get an instance of the client or to represent an instance of the client, which is represented with the iTrainDelay service client type. Then I have what the clients can do. The clients can connect with my service, simply connect and done. And that is, of course, marked with is one way. They won't wait for a response. Then the callback contract, that's basically what the service can call on the client, is marked as a service contract and has a send train delay. So my service will actually call onto a method send train delay. That is what I'm going to expect to happen on the client, and that I'm going to expect the send train delay received. Also marked with the is one way equals true, because of the fact that the service is not going to wait for the response, for the client to give an acknowledgement of this service. Okay, let's take a look at the implementation. So I have a train delay service which implements the iTrain delay service, and it has the connect. What happens when a client is connecting? Remember, it is single-threaded instance. All clients are connecting with the same instance. So I'm actually using that get callback channel in the callback contract to get an instance of that client within my server-side code. So I'm actually creating a callback channel to the client client callback contract. And that I am going to, because it is single-threaded, I can then use a method I've created here, register, and that register is going to store that in a list of clients, as you maybe can read it here. It's going to store that in a list of iTrain delay service clients. Oops. There we go. So this is my service implementation. That is what is running on the service. So we had a file system watcher, and that file system watcher is going to trigger when a file is dropped in that specific directory. What I'm going to do is I'm going to parse that file using link to XML, and then when I have the information read out, I'm actually going to loop through that collection of clients, and to all of these clients I'm going to send that train delay. And that is causing the update to be sent out. It's basically parking that message, it's queuing that message on the service, and then it's going to send it out. In configuration code, it's basically pure WCF, apart from the binding, which is the polling duplex HTTP binding, which requires me also to add a reference, and you may not be able to read it. Let me make it a bit bigger, which is this particular reference, the polling duplex inside of the system service model. And there is a server and a client-side reference for that. That I also have to add the client instance on the client Silverlight application. And then on the client, I start, just as I would do with the regular service, by adding a service reference. This doesn't generate me any client configuration code. As you see here, and the guy that had to write it was probably sick, and so there's no client configuration being created. So it's empty. That means that I have to write some more client configuration code myself. So in this, in the code behind of the XAML file, I'm going to create an endpoint address. Of course, you can do this via configuration. It's just for a demo. Then we create a custom binding instance, passing in the polling duplex binding element, the binary message encoding, and the HTTP transport. And then, because it's WCF, I can say train delay service client, instantiate the proxy, create an instance of that proxy. The proxy gets generated, of course. I'm going to connect asynchronously. I'm not going to wait, but I'm going to wait. I'm going to register for that send train delay message from the service. I'm going to wait for that response to come in. And in that callback, which is pure asynchronous development here, in that callback, I get in the information as some XML that I'm going to use here in the delay info, which is, I think, it's a specific type. I'm not really sure. It's a train delay type instance that I'm getting back here. So this is one way of doing duplex communication. As you can see, it is not really that easy to work with. Let's take a look at the second way of doing duplex communication. Remember that this one was actually the only way of doing duplex communication over the internet. Let us take a look at sockets. I think everyone is more or less familiar with the concept of sockets. They have been in .NET since every release, and they are also part of Silverlight since Silverlight 2. And they allow us to do real duplex communication, where the communication is really initiated by either the client or the server. So that is pure TCP communication that we have here. That is very well possible to do here. So it's going to be faster. However, it is only possible to do this on ports between 4502 and 4534. You cannot do duplex communication over any port that you want. So if you want to do this over the internet, well, I think it's going to end up not working, because somewhere along the line that port is going to be blocked on some firewall. So I think only doing this in intranet is a good answer. Not doing this in the internet, because it is probably not going to work. It is also lots of manual work. So why would you choose this? Because of the speed. It's much faster. It's pure TCP, pure socket communication is going to be a lot faster. It's also a lot of manual work, as I said. For one thing, you need to create something called a policy server. If you've done some Silverlight, and I hope you have, Silverlight, as you know, checks for the presence of a policy file when making a cross-domain call. This is by default cross-domain. So in fact, Silverlight will actually send a request to for that policy file to see if the client access policy is there. Now, normally you have a web server that would know how to serve an XML file. Now, in Silverlight, in the scenario of sockets, you're not using a web server. You're maybe using a Windows service as your socket server, or perhaps in a console application, but you're probably not going to use IIS. You basically can't use IIS. So that means that you have to write yourself a policy server, which is actually a separate application that serves the policy file. So what happens is that Silverlight will send a request to port 943 for the policy file, and that application is needs to respond with a valid client access policy file. You have to write that yourself. Now in Silverlight 4 and 5, this is if you're building an out-of-browser application with elevated permissions, you don't have to write the policy file, because Silverlight 4 and 5 elevated applications, or applications with elevated trust, don't do the client access policy check, so you don't have to write it. But if you're doing an in-browser Silverlight application, you still have to do it. Also, since Silverlight 4, it is possible to host the policy file on IIS on the same domain. So it will actually do the check on your IIS, so on HTTP. So you can do that using the Socket Client Access Policy Protocol, which is HTTP or TCP, which is the default. So basically, it will always check on TCP unless you specify this to be over HTTP. We're going to see the one with the policy server, because that's the most complex one. Then the socket server, as mentioned, is going to be a console application or a Windows service. I'm going to use a console application, which is going to wait for incoming requests. Waiting for incoming requests can be done using something called the TCP listener, which is basically waiting for incoming clients. And then when a client has connected, we need to keep track of that client. And we're going to do that using a stream writer. As mentioned, it can only listen on ports between 4502 and 4534. It can listen on other ports, but Silverlight will only use that range of available ports. So that's something else that we have to write. And then the client, we need to write that as well, of course. The client, there's no WCF, so again, we need to do everything manually. What we need to do is we need to connect, we need to send, and we need to receive data. Now, everything, of course, is done asynchronously, because it is simply service communication in Silverlight. There is no TCP client available in Silverlight itself, so you have to use the socket, the raw socket class, to do the socket communication, which again makes things a bit more complex. And then it is all asynchronous, as mentioned, so you have to pass the socket instance between asynchronous calls, and that you can do using the socket async event args class. I'm going to show that in just a second. It's not finished yet. You also the callbacks in your Silverlight client don't happen on the UI thread. They happen on a background thread, which means that you have to use dispatcher begin invoke to do stuff with your UI in case of an incoming response. Okay, I'm going to show you a sample where we are using sockets to do duplex communication with some stock information. That is the typical sample of socket demos. So I'm going to run the Silverlight application first. Once it's open, there we go. I'm going to start the Silverlight application. Then I also, of course, have to instantiate my policy server, which is going to send the policy file when Silverlight requests it, and then the socket server itself. So this is the policy server. I'm going to start an instance of that one. Start new instance. It, as mentioned, is a console application. which is for some reason waiting to start. There we go. And now I'm going to start the socket server. And there we go. So when I now click on this Go button here, we should start receiving, as you can see, stock information, which is being pushed by the stock server. The client has connected, as you can see here. It has connected with that policy server. It has asked for the policy file, and it has that was okay, and then it could continue starting to communicate with the stock server. Let me show you the code for this. It's actually quite complex. So first we have to write the policy server. It's a command line, a console application, I'm sorry. Let me show you the code very quickly. So we start the policy server. I'm doing that using a TCP listener. That is going to listen for incoming requests, always on port 943, as you can see here. I'm going to start listening asynchronously. And when a client has connected, I'm going to call this, use this callback method. Now, what is this stock server, policy server going to send? It is going to send this particular file. It's actually going to read out this XML file and it's going to push that to the client. What the client is going to send, and that is purely by definition, the client is going to send, so Silverlight is going to send this particular string. So I'm actually waiting for a client to send that string, and then I'm going to send back the client access policy file. Okay. So I'm waiting waiting asynchronously for a new client to connect, and when someone has connected, then we actually get the TCP client, and then so we have now access to the connected TCP client, and we start receiving data. What data are we receiving? This policy file request XML element, basically. So that's what you see happening over here. And then when I have actually received that string, I'm actually going to get in this callback. And in that callback, I'm checking if the policy request coming from the client is equal to that XML string. And in that case, I'm going to start sending information, which is the client access policy file. And then I'm again asynchronously waiting for a new client to connect. That is the policy server. Then we have to work with the stock server. Of course, we have to write the stock server itself as well. In this case, I implemented the stock server as being based on a timer, which sends updates every so often. So the stock server also listens for incoming clients. In this case, I defined the listener to be listening on a port 4530. That's okay, it's between 4502 and 4534. So that is okay. Silverlight will be able to send or communicate over that port. I'm going to start a TCP listener. I'm going to asynchronously wait for a new client to connect. When a client has connected, I'm actually going to capture the stream writer, because I have to be able to push information over a stream writer. That's what I'm doing here. I capture the TCP client in the second line of this method here, and then in the third line, I'm creating a new stream writer by saying TCP client.getStream. And I store that stream writer in a collection of client connections, a collection of stream writers. That's what I meant. It's a list of stream writers, and I store it so that whenever the timer ticks, when I need to send an update to the client, so that the stock timer elapsed, I'm going to loop again over all the stream writers, and I'm going to start writing the stock information. And that's what you saw happening. It's pushing the updates to the client. Let's take a brief look at the client then. So the client is, again, it's all manual work. So I have to create a DNS endpoint, which is going to communicate over the port, which is just falling off the screen. It's going to communicate with port 4530. I create a new socket. Then I need to be able to pass my socket instance between my asynchronous calls, because this is actually based on the iasync result. So I create a socket async event args, and in the user token, I store that socket. Then I do the asynchronous connection, and when that is completed, I execute this callback. So my client is going to try connecting. First it's going to go via the policy server, then it's connecting. When the client has connected, so that's okay, the client is now connected with the stock server, not the policy server. It has already gone by the stock server, the policy server. I disconnect the on-socket connected, but I start waiting for incoming information. So on-socket start receive is the callback, and then in the last line there, I ask the socket to start asynchronously to receive information. And when information is coming in, I capture that data, but this is happening on a different thread than the UI thread. This is not happening on the UI thread, which is actually resulting in me having to use the dispatcher begin invoke to update the UI with the new stock information. Okay? So that is a second way of doing duplex communication. I'm going to show you the third way, which is actually more or less like a combination of the two. So until now we had the polling duplex, based on WCF, available to do internet duplex communication. Because of the fact that it's based on WCF, it's quite easy to work with. We also have sockets, which we've seen just a minute ago. It's faster, but it doesn't have a WCF configuration possibility, so it's requiring us to do a lot more coding ourselves. And of course, it's not available in all scenarios. Now, the third binding that can be used to do duplex communication is this NetTCP binding, which was actually introduced with Silverlight 4. And so the NetTCP binding is a new type of binding added with Silverlight 4 that is possible to communicate over with Silverlight. So you have the basic HTTP binding, and Silverlight can also use this NetTCP binding. And NetTCP is basically combining a bit of the advantages of sockets and of the polling duplex. So it is based on WCF, so it's a lot easier to work with, but it's also built on top of TCP, so on top of sockets. So that means that it's as fast as sockets, but it is, again, suffering from the port limitations that we have. So again, only between 4502 and 4534. Take a look at the difference in performance between polling duplex and NetTCP. So the blue one is NetTCP. The red one is HTTP polling duplex. This is a logarithmic scale. So you see that I think it's 870 times faster. So it's a lot faster. It's not just a bit faster, it's a lot faster to use NetTCP. Also, it's more scalable. The number of connected clients, again, the red is HTTP polling, blue is NetTCP. There can be many more clients connected at the same time if you use NetTCP. Now, again, that might bring you in a difficult position. Why can't I use this for internet scenarios? Well, what I'm going to show you is another demo, and you'll see that this demo is code-wise very familiar to what we had with the HTTP polling duplex. It also has the callback contract. It also has the operation one-way equals operation contract one-way is true. It also has the cut callback channel. What I'm doing here is I'm creating two endpoints. I'm creating a NetTCP endpoint and as well as a polling duplex endpoint. So again, this is the same code as you saw earlier, now on stock service. So there we go. So you have the service contract, callback contract is one-way is true. Exactly the same thing as with the HTTP polling duplex. So you can reuse that code. The implementation, again, is completely similar. We're going to send an update to the client, as you can see in this particular line. But then in the configuration, that is where it gets important. So what I've done here is I've created two endpoints, the HTTP endpoint and a NetTCP endpoint. So basically what I'm doing now is if I'm working on an intranet, if the incoming connection is intranet-based, I'm actually going to use the NetTCP, which is a lot faster and better scalable. If I'm coming from the internet, I'm going to use the polling duplex binding. So just using some configuration, so the polling duplex binding as well as the NetTCP binding are defined over here. So just by using some configuration, my same application can now work with the advantage of polling duplex or NetTCP. And the client is even more simple. We even get client configuration code generated, as you can see here. There is an endpoint which communicates over NetTCP. So my client in this case is actually going to be even simpler. It's just like a WCF service communication from Silverlight, instantiation of the client proxy, asynchronous connect using connect async, and register for the send update received, which in this case will happen on the UI thread. So no dispatcher begin invoke is required. So that is the basic tip that I can give you here is using the two combined, so polling duplex as well as NetTCP, for to cover in fact all scenarios and benefit from the speed of NetTCP and also benefit from the availability over internet with polling duplex. Okay, so that was it about for duplex communication. Let's take a look at some other scenarios. Splitting up the ZAP using MEF, the Managed Extensibility Framework. Now, before we dive into MEF, just a brief word on why you would split up your ZAP. The user really doesn't like a ZAP file that is 10 megabytes or 20 megabytes, okay, with current internet speeds, that is still not a lot. But if he has to wait every time he arrives at your application for your application to download, it's actually going to enerve him. So you want a better user experience. A better user experience is actually quite easy to create in Silverlight. One thing is, of course, not including large resources like large images. The second way of making a better user experience or creating a better user experience is making sure that the application is running as fast as possible. And you can do that by splitting up your XAML, your Silverlight application, in, for example, like a shell, a hosting shell, and then only download the parts of the applications or of the application that the user is actually interested in. When he clicks on user management, download user management. When he clicks on product management, download product management. So you can partition your ZAP, that's actually very easy to do from Visual Studio, and load it on demand or perhaps also load it in the background. I'm going to show you a sample where we're going to load in the background. There are several ways of doing that. We can use the iNavigation content loader, which I'm going to show you next. We can also use Prism, and I'm going to show you a solution using MEF. A very brief word on MEF. So MEF is, as mentioned, the Managed Extensibility Framework. MEF is based on the concept of parts. So an application can be seen as a part. A logging engine can also be seen as a part. And MEF is basically your composition engine, which will bring those two parts together. One part is saying, I'm exporting myself as a logging engine. Another part can say, well, I want to import a logging engine. And MEF is basically your composition engine that will merge up these two parts. It will actually compose your application out of loosely coupled parts. The good thing about MEF is that MEF can also take care of a recomposition. So initially, for example, as we said, we can download the shell, and MEF can be on the lookout for new incoming parts. And when there are new parts available in your application, MEF will recompose your application so that it will actually be able to load in those new files inside of in memory. So basically, MEF has two roles. It's more or less an IOC container, but it's not only an IOC container, it is also a solution of splitting up your XAML. MEF is not going to split up your XAML, you have to do that yourself. But MEF can take care of downloading separate ZAPs and loading them into your application. And that is done using something called the deployment catalog. If you've never worked with MEF, so a catalog is basically, like the word says, it's a listing of all the separate parts that your application can be composed of. And a deployment catalog is aimed at downloading stuff and then loading it into another catalog. And the most often used is the aggregate catalog. And I'm going to use the aggregate catalog in this sample. Now, this sample is called the MEF Marketplace application. Like regular marketplaces, you have rights to use several applications. And all these applications are managed or are described as being a separate part. Let me first run the application and you'll understand what I mean. So this is my MEF Marketplace app. So imagine that this is a marketplace, like a Windows Phone's marketplace. And first I'm going to ask a service which are the applications that I have a permission to work with. So I'm going to load in these applications. So the service has said, well, these are the applications that you can use. And now MEF is actually doing in the background, it probably has already finished that, it has downloaded me all these separate applications, which are in fact different ZAPs. It has downloaded these to the client, and now I can use them. MEF has also done a recomposition, because it saw first the Flickr image application, then the Hello World application, and then the Facebook application coming in. And it has done a recomposition every time to load in that new application, that new ZAP file. In fact, it has loaded in some new parts. And so, for example, this is a separate application being loaded in with MEF. It's basically simulated, so it doesn't really do any search. You can also, for example, do Facebook. Again, this is just a screenshot built inside of that application. Okay, let's take a look at the application structure first. So, the application has, the solution has several projects, and you see there the Facebook app, the Flickr image search app, the Hello World app, and the Twitter application. Those are separate applications. In fact, for MEF, they are parts. They expose themselves as a specific application that my main application is interested in. I'm not downloading everything initially. I only download this MEF Marketplace application. I'm only downloading that initially. Each of these applications results in a separate ZAP file, as you can see here. So the Facebook app becomes a ZAP file, a Flickr application becomes a ZAP file. They all become a separate ZAP file that I'm going to download with MEF and load into memory, load into my application using MEF. Okay, how am I doing that? Well, let's first take a look at either of these applications. So let's take a look at the Facebook application. So the Facebook application is a class that implements the iMarketplace application. That's one thing, but it also exports itself as an iMarketplace application. So basically it is saying, I am available for someone to use me who is looking for an iMarketplace application. That's what this application is saying. So let's take a look at that interface. It has an application name, which was shown in the drop-down. It also has a marketplace icon and a main view, which is the first XAML view that has to be loaded in. Okay. So every application follows also the Facebook app, the Flickr app. They all follow that same interface, right? And let's take a look at the implementation. So the class itself exports itself as an iMarketplace application. Then we have the application name, which is hard-coded the name of the application. And then notice what is happening here. The marketplace icon, which is of type framework element, as well as the main view, which is also of type framework element, also do an import down. They ask to get filled up, to get that they want something to be created for them. In this case, they want to have the icon created, which is the class. I'm going to open it myself. So that's this icon.xaml, and the Facebook application itself, so the Facebook landing page, that's this one. They export themselves, as you can see here, one as a Facebook landing page, and the other one as, I haven't opened it yet, as the, this one exports itself as an icon. So they are saying, I'm exporting myself. MEF is saying, okay, I'm going to wire these up, I'm going to import them. Okay, so that's how each of these applications work. Now, the Silverlight application has a view model, main page view model, which has an observable collection of iMarketplace applications, which is marked with the import many attribute. It basically says all the iMarketplace applications that you can find, MEF, put them in me. Put an instance of those, of each one of those inside of me. Allow recomposition is true, meaning that if it finds one of these after the application has started, it will actually allow a recomposition. It won't fail. It will keep on loading these in as many as we find during the run of the application. And that is what you see here. Now let's finish off by taking a look at the app CS, where I'm actually downloading all the files. So first, I was asking my service, the marketplace service, to give me a list of all the applications I as a user have the permission to use. So there is a service defined over here, the marketplace service. It's a regular WCF service, which returns, in this case hard-coded, a list of so-called MEF applications, a type that I defined in my service, which has an application name and a ZAP file name. And so I am returning a hard-coded list of 3 MEF applications, including the ZAP file name that I want my MEF to download. So that's what I'm doing here. I am creating an aggregate catalog. An aggregate catalog, as the word says, can aggregate other catalogs. For each ZAP that I'm going to download, I'm going to create something called a deployment catalog, and I'm going to place them inside of the aggregate catalog. So what I'm doing here is I'm creating a container that is typical MEF stuff, and then I'm instantiating my client. And I register, I do that call asynchronously, and I get in the result, which is an observable collection of MEF applications. They contain the file name, the URL that we need to download. And so what I'm going to do is I'm going to loop through all the available applications for the user, so through that observable collection. And for each of these, I'm going to create a deployment catalog. And that deployment catalog, I pass in the file name of the ZAP. I add that deployment catalog to the aggregate catalog. And then I do the asynchronous download of that, or I call the asynchronous download on that deployment catalog. So MEF is going to pull down that ZAP file, it's going to inspect what is in there, and it's going to see that something is exporting itself as an iMarketplace application. The import many on the observable collection inside of the view model is then saying, oh great, I am going to get another one, because MEF is pushing an instance of that newly downloaded marketplace application into that collection. All right? Okay, let us continue. You've seen that. There we go. Let's take a look at some security stuff. Silverlight applications often have to work with services. Now, communicating in a secure way with services is vital for most businesses because they don't want their information to be out on the street. It was said that Silverlight 5 would have DWS HTTP binding support. Unfortunately, that didn't make the cut, so we don't have DWS HTTP binding available in Silverlight. But still, we do want to have some security when communicating with services. I'm going to show you a way that is possible. There are other ways of doing it, but this is one solution that could help you in making sure that your information is always going to be secure, as well as your service endpoint. Now, when we talk about securing communication, of course, SSL comes to mind. So SSL is certainly supported in WCF by specifying the service to use HTTPS transport. Silverlight also supports using HTTPS, so that is also perfectly possible. So that is one side of the story, of one part of the story. We can secure information in Silverlight using SSL. So let's do that first. So I'm going to open IIS. There we go. I'm not going to explain you how to set up HTTPS, but I'm going to start another website. Basically, they're all on the same port in this particular case, which is not good. You can create your own certificates and attach them in IIS, which is what I've done here. So let me open the solution, HTTPS. There we go. So I have now configured this WCF service to communicate over HTTPS, which is in the web.config, of course. So as you can see here, I've simply specified this to be communicating over HTTPS in the service, in the client config, sorry. I'm going to, as you can see, also use this one, HTTPS. It's also going over HTTPS. And this works perfectly. There is no reason why Silverlight wouldn't be able to communicate over HTTPS. This is one side of the story. This will actually encrypt the data between my Silverlight application and my service. I'm going to continue. Okay, come on. So where did we put our nuke missiles? That is quite secure information. We didn't know. Okay. So as you can see at the top, it is communicating over HTTPS. And also the service communication is going over HTTPS. So the information is now secure. Now, as mentioned, that is one part of the story. We don't want to expose endpoints, service endpoints, to people who don't have the permission to actually read from our service. So we need to make sure that users can be authenticated with our service endpoint. Now, the problem is that Silverlight that actually requires message-based security, which is not supported in Silverlight since it doesn't support WS-HTTP binding. However, what we can create in Silverlight is to put the username password inside of the header of the message. That is supported. You can then say, yeah, then I'm actually sending over the username password in clear text. Well, actually, if you combine that with HTTPS, you have a secure solution. You are sending the username password to the service over SSL, so no one can actually figure out what the username password combination is, and the service will actually check if that username password combination is there or not. Let me show you that in action. So I'm going to open the demo. There we go, and I'm going to start another website. And let's start this one. Is it open already? No, this one. Okay. So again, I'm using HTTPS now, but now I'm going to pass in username and password from my client. Let's start it. There we go. So I'm going to try launching something. I'm going to type in some invalid password. I'm going to try launching that missile. Now what is going to happen? WCF is checking to see if the header contains the username password combination. I'm going to explain you how it is doing that in just a second. But as you can see, an error is being thrown on the service saying that the provided credentials are invalid. Silverlight then says, well, yeah, remote server return an error not found. And in my Silverlight application, I see that that service call has failed because the authentication information is invalid. If I use the correct information, I think it's 1111, I'm actually going to be able to launch that thing. Okay, now how did we actually do that? In WCF, you need to do some security. As you can see here, the service credentials contains a username authentication. Username password validation mode is set to custom. I'm using a specific type, the username password validator, which is a class that inherits from username password validator. The validate method, I have to override that, and it's called automatically. That's what you see here. I'm going to check, in this case, for a hard-coded username password. I can go out to a database, I can do whatever I want. So my WCF is actually going to use this type for its validation. It only does that if I set the security in the binding where I set user authentication mode to username over transport. This triggers WCF to check if the message header is there, and if it is not there, it's of course not going to allow the call. If it is there, it's actually going to use that validate method to see if it is actually working. Inside of the Silverlight, well, things are actually quite simple as well. I can pass in client credentials, username.username, which is probably the most weirdly named property in the whole of Silverlight, but anyway. So username.username and username.password actually results in that username password being embedded inside of the message header. And this actually results in a secure way of doing communication with a service. Okay. So, the next thing I'm going to show you is how we can leverage ASP.NET authentication in Silverlight. Many of you probably use the membership API in ASP.NET, and you may know this, but just in case you don't, ASP.NET exposes the ASP.NET membership API over a layer of services which were added in .NET 3.5 called the application services. Now, application services are basically exposing what membership can do over a service layer. That was added in ASP.NET just for the use of AJAX, but it can be used for Silverlight as well. So it's basically allowing us to do communication or expose the ASP.NET membership API to client-side code. So AJAX and Silverlight can actually use that. It's exposing authentication, roles, and profiles. Let me show you how it works. Let's use ASP.NET Authentication. This one. So I'm going to run it first, and then I'm going to show it to you. Okay, so we're going to try to log in. The username information is stored in ASP.NET Membership. So I'm going to try logging in with a secure password. That hit login, okay. So now it's, oh, that's not good. I think it's chill. Okay, so as you can see, I'm now logged in as a regular user. It uses a very nice background color, which is stored in ASP.NET Profiles. I can put it to green, and it's also storing that in the profiles information inside of my ASP.NET Membership API. If I log on as an administrator, you can see that the administrator has more functionality available. I think I typed it wrong. Let's try that again. Okay. As you can, yeah, by coincidence, it's also green. But you see that there are more buttons available because he has received information that it's in another role. The roles are managed entirely in ASP.NET, as well as the users, as well as the profiles, but I'm leveraging that in Silverlight. This can be very useful if you have an existing ASP.NET membership implemented and want to move to Silverlight. Then you can reuse or re-leverage what you have already available from ASP.NET membership on the server side. Let's take a look how this was implemented in code. So as you can see here, the only thing, because I don't have to write any code for this, the code is already available in ASP.NET itself. I have 3 endpoints available. And those endpoints are, I've named them here, authentication service, role service, and profile service. They simply expose, they're simply an endpoint. They expose, in this case, the authentication service part of ASP.NET. I have to enable these in my configuration code. So as you can see here, in the System Web Extensions Scripting Web Services, I have to enable these services. They are disabled by default, as you can see here. Authentication service, role service, and profile service are enabled, are set to true. I also create the endpoints, as you can see here. And then for the rest, it's pure WCF. Basically what I'm doing is I'm creating 3 service references, authentication service, role service, and profile service. And I'm, by creating them, I get client configuration code generated for me. And that's what you see here. I have authentication service in configuration code, profile service, and role service available to me. And when I do, for example, a login, I instantiate the authentication service. I set login async and login completed. This is pure service communication with Silverlight. But I am leveraging something that is exposed in ASP.NET, and I'm reusing that in Silverlight. Okay. We have about 5 minutes to go, because we need to stop early, which is a bit of a pity, but anyway. Let's take a look at this one. This is an interesting one. The iNavigation content loader. I assume you've all worked with the navigation template in Silverlight, which was introduced in Silverlight 3, if I'm not mistaken. Yeah, in Silverlight 3, and also leverage available in Windows Phone. But this thing is not available in Windows Phone. But in Silverlight 4, they made it possible to extend the navigation applications in general. They added an interface called the iNavigation content loader, which enables us to get a hook in the navigation process. So by default, Silverlight uses its own navigation content loader. And what does it do? It looks at the source, the target URI that you're giving it, and based on that, it will look for that specific XAML file, and it will create a page from that and navigate to that page. Now, if you don't like that behavior, you can say, well, I'm going to create my own iNavigation content loader implementation, pass that to the frame, so that my Silverlight application can actually do something different. For example, check some specific service, or check an authentication if the user is allowed to access that specific file. There are several ways, or several applications of this. I'm going to show that in just a second. Now, the iNavigation Content Loader interface has 4 methods that you can see down here. It has a begin load. It is asynchronous, so it implements the it actually uses the iAsync result. So based on the target URI, that's the most important part, it will normally check which page you are wanting to load, the target URI. So the begin load actually creates the instance of the page, and asynchronously that callback will be called when that loading is done. Then the end load will be called, and in the end load, the instance is returned as a load result. And that's normally out of the box the instance of the page that you want to navigate to. You also have the can load. The can load you can check if someone wants to, if you want to do authentication, for example, or if you want to see if that page is available. You can use that for error handling, for example. And the can load is an asynchronous, cancel load is an asynchronous way of doing, of canceling the loading of the page. Is this something that you would use? Well, there are several places where this would really come in handy. In an MVVM scenario, you can use this to link the view and the view model. That's perfectly possible. You can use this to extend the navigation framework to be able to pass parameters, because that is by default not possible. You cannot pass parameters to a page that needs to be loaded. You can pass constructor parameters. You can override it entirely. You can, for example, access the service to check if a page is or needs to be, or download some data before the page is loaded. You can do that. Accessing a service might not be a good idea. It might slow things down, but it is possible. You can authenticate. You can handle errors. All these things are available with the iNavigation Content Loader. And we're going to finish off by taking a look at this in a small demo. And that is the iNavigation Content Loader. Okay, let's take a look at this thing. So in this case, I have my own iNavigation Content Loader, which doesn't use a XAML target URI. It uses a type. So this is the iNavigation Content Loader. As you can see, it's a class which implements the iNavigation Content Loader. And in the begin load, let's take a look at the begin load. I'm going to check if the target URI is a type that I can create. Let me scroll up a bit. So I'm going to create a type from that target URI. I'm going to check if that type really exists. Then I'm going to create an instance of it using activator create instance. I'm going to pass to that result that I'm going to return, the iAsync result, that instance, and I'm going to call that callback. In the end load, I'm returning that instantiated object of that type that I want to pass. In the can load, I'm going to do some security checks. Perhaps I can do authentication here. In this particular case, I'm also checking for that type. If it is null, which means that the type is wrong, the can load is going to return false. It's not going to load that type. The same goes for the default constructor. If it doesn't have a default constructor, it's going to result in an error because I cannot create an instance of it. So it's also going to return false. So basically, Silverlight will first do the can load and only then start with the begin load. So this is my own implementation. I need to pass that to the frame, as you can see here. So in the navigation frame, I pass my own content loader, an instance of the type name content loader. From now on, Silverlight will not use the default, but it will use my content loader to use for navigation. And in this case, I also made the links so that, let's take a look, for example, at this hyperlink button. The navigate URI is no longer something ending in XAML, but in this case, I create here the type name content loader .views.home, which is the type I want to create an instance of. So Silverlight will take that as the target URI and pass that to my can load in the target URI, which is in this case a string containing the string that I'm passing as the target for my hyperlink button. Okay, so sadly we have to stop early. so I can't finish everything. So it's useless to actually go to the summary. I hope I've shown you a couple of things that you didn't know yet, and that you've learned a few things in this last session of today. If you have questions, we'll take them offline. So I hope you enjoyed it. I hope you enjoyed the rest of the conference, and I hope to meet you outside, perhaps for a little chat. Thank you.